Hello my dear students, good morning to all of you. In today's session, we are going to discuss about very important topic, that is Townsend's current growth equation. Getting my point? So in this, basically what we need to understand here is the first module we are going to study on the what it is various electrical phenomena in the presence of what gaseous insulating media, right? Which are those processes? One, it is conduction phenomena, and one more is breakdown phenomena in the presence of what gaseous insulating media, right? So here the breakdown process, how will occur? The insulating between the present, which is present between the two electrodes, how it is going to be gets breakdown due to the flow of the high value of the current itself. Is it right? So how that current growth it is going to be occurs? Nothing but the breakdown mechanism in the presence of gaseous dielectric media between the two electrodes. That mechanism, what mechanism? That is breakdown mechanism, can be well explained with the help of the two scientists. Which are those? One, it is streamer theory is there, one more is Townsend's theory. Okay, the first let us will study about the Townsend's current growth equation. Okay, this current growth equation is mainly used for the analysis of what? Ionization process. Okay, in the previous class we have already discussed about the what is ionization process and what are the types of ionization process and what is the impact of ionization process. So is it right? We have discussed already about this one. Anybody can tell what is ionization process? Is it right? So ionization process, it is nothing but what? It is the ion, atom or the molecule which gains a positive or a negative energy. How it is going to be positive or negative energy gain? It is going to be done with the help of by losing or gaining the electrons itself. Is it right? What are the types of ionization process? Ionization processes, which are those we have studied? The first one is ionization by collision, and the second one is photoionization process, and third one is secondary ionization processes, and fourth one is electron attachment process. So these are the various types of ionization process we have studied, right? And the last one is, and we already studied about the what is the impact of ionization process, how the electrons are going to be gets emitted from the cathode. Is it right? How it is going to be emitted? So the first thing is electron emission due to the impact of what? Photons, and one more is electrons are going to be gets emitted due to the impact of positive ions, and one more is we have studied about electron emission due to the metastable atoms as well as the neutral atoms. Okay, so now we'll study how now let us consider this two electrode system. Okay, those two electrodes, one it is anode and this is the cathode here. Is it right? So in between these two electrodes the gaseous medium will be present here. The gaseous medium, it is going to be acts like what here? That is insulating or the dielectric medium which is present between these two electrodes. Okay, now what we have to observe here, the breakdown of this dielectric medium, when it is going to be takes place, whenever suppose this is the adjustable high voltage source is there. When we apply high voltage, then what will happen? Then electrons will be gets induced here. So after the application of this high voltage here, the electrons are going to be starts moving from cathode to the anode itself. Is it right? See here, the electrons which are going to be starts moving from the cathode when we apply the high voltage here. Okay, then due to the high voltage the amount of the current will also be high itself. Is it right? So due to this high current what will happen? There may be a chances of getting breakdown of this insulating media present between these two electrodes, right? Once the insulation gets breakdown, means why it is going to be failing? Only because of the reason that because the amount of the current flowing between these two electrodes will be very high itself. Due to this higher amount of the current, the insulating media it is going to be gets breakdown. Is it right? So we can say only high amount we said, but how much amount of the current which is flowing here? So due to the how much amount of current, the insulating media, it is going to be break down. So that calculation of the current, so that is going to be done with the help of what? Townsend's current growth equation. So by using this Townsend's theory, what we are going to calculate? The amount of current which is flowing between these two electrodes. Due to this high amount of the current only, the breakdown of this gaseous medium, it is going to be takes place. Is it right? So by this equation, what we are going to calculate? That is nothing but the amount of current. So the current growth, how it is going to be occurs after the application of the high voltage between these two electrodes under the presence of what? Gaseous medium. Okay, let us start now. So let us assume that the first thing here, let us assume that how many number of electrons? So n0 number of electrons which are emitted from the cathode here. After the application of the high voltage, the electrons are going to be starts moving here. So we don't know how many number of electrons are going to be emitting from this cathode. Is it right? So for that purpose, let us assume how many number of electrons? Initially n0 number of electrons which are going to be emitted from this cathode. Okay. Next thing here. Among these n0 number of one electron, so one electron which collides with what here? Neutral gaseous molecules or the particles here. Then as a result, what will produce? So as a result, will get the positive ion as well as the electrons. As we already studied about the ionization by collision process, right? These electrons are going to be colliding with the neutral gaseous molecules and it will produce the some secondary electrons along with the positive ion, it is going to be releases. Is it right? So this is going to be called it as a ionization by collision process. Okay. So what I told here, so we have considered the two electrode system. The first thing it here, let us assume that n0 number of electrons which are emitting from this cathode. Among these n0 number of electron, if suppose one electron, if it is collide with the neutral gaseous molecule, means as a result what we will get? Some primary electrons along with the positive ions and secondary number of electrons are going to be releases here. So this process, it is going to be called it as what? Ionization by collision. Is it right? So how many number of ionization collision takes place means, let us consider for that one, let alpha be the average number of ionizing collisions. Okay. So this ionizing collision process will mainly depends upon the two factors. Which are those factors? The first one is gas pressure, which gaseous medium which is present between these two electrodes. The examples for this: electrical insulating medias. Which are those mediums? We have a gaseous insulating medias or solid insulating medias are there. One more, liquid insulating mediums. Is it right? So first thing we are studying about only the gaseous medium. So then we are studying about the various electrical phenomena. Which are those? One is conduction phenomena and one more is the breakdown phenomena in the presence of which dielectric medium? That is gaseous medium. Okay. So here whatever the ionizing by collision process takes place, that will be depends upon the two factors. Which are those? The first one is gas pressure and the second one is applied electric field to the gas pressure ratio. Okay. So this ionization by collision process will depends upon the two factors. The first one is gas pressure, that is represented by P, and one more is electric field to the gas pressure, this ratio. Okay. So this ratio E divided by P, this is going to be called it as what? Townsend's first ionization coefficient. Keep it in mind. So this is very important. This E divided by P, nothing but electrical field to the gas pressure ratio. So this is going to be called it as what? Townsend's first ionization coefficient. I hope this is clear to all of you. First, nothing I had considered here. Basically the Townsend's current growth equation, it is mainly for the analysis of ionization process. Next thing what I told here, the amount of the current when we apply the voltage here, the electrons are going to be gets induced here and these electrons are going to be starts moving from this cathode to the anode itself. when we apply the higher voltage, the amount of the current will also be very high. So due to this high amount of the current, the insulating media between these two electrodes will be gets break down. So that is why, but we don't know higher amount of the current only we are telling. So how much amount of that current which is flowing between these two electrodes, that estimation or that calculation of the current, that is going to be done with the help of what? Townsend's current growth equation. I hope this is clear to all of you. Next, what I told here, so first for what we had assumed here, a naught number of electrons which are emitted from this cathode. Suppose when one electron, if it is collides with this neutral gaseous molecule, then what as a result what we will get, some primary electrons are going to be releases, and this A plus represents what? That is positive ion, and this secondary electrons. Okay, so this process it is going to be called it as ionization by collision. So how many number of ionization by collision process takes place? That is average number of ionization collisions, that will be represented by what? Alpha. Keep it in mind, representations. Okay, let alpha be the average number of ionizing collisions. So this ionizing collision will be depends upon the two factors, which are those, one is gas pressure and the second one is E divided by P, nothing but applied electric field to this gas pressure. So that is going to be called it as what? Townsend's first ionization coefficient. I hope this is clear to all of you. Okay, let's move on. See next what it is there. At initial condition, at a distance x from the cathode, initially means x will be equal to 0. Is it right? So next it will be, and the number of electrons will be considered from the, at any distance x from this cathode, at any distance, the total distance between these two electrodes will be, that is represented by small d. Okay, but at any distance x from the cathode, small distance will take, that will be represented by x. So in that case, let the number of electrons will be how much? So that is nx. Okay, at any distance x from the cathode, let the number of electrons will be how much? That is nx. Okay, when these nx electrons travels further distance of how much? This small distance x into d, that is altogether dx distance. Is it right? When these nx number of electrons travels further a distance of how much? D into x itself. So then we can say that, then how can say? So the total number of electrons which are traveling from cathode to the anode, how will write that one? Alpha into nx into dx. Getting my point? So that is why, so the first thing here, that at initial condition what we have taken, x is equal to 0 and this nx is equal to n naught, because n naught electrons are going to be emitted from the cathode, what we had assumed itself. Is it right? And also we can write the number of electrons dnx, this will be equal to alpha nx into dx here. When we take, so from this RHS side what it is there? Alpha nx into dx, and this LHS side is dnx is there. We'll take this ratio, dnx divided by nx is equal to alpha into dx. Okay, then integrate the terms here. Then after the integration here, integration of dnx divided by nx equal to integration of this alpha into dx here. Once we do the integration, then what will get? Ln of nx, this will be equal to, alpha is nothing but the constant here, alpha into x plus integral constant, I will represent it as a itself. Getting my point? Next now we'll apply the initial conditions now. What is the initial condition? X is equal to 0 and nx is equal to n naught is there. Then this, instead of this nx, what I have to substitute here? This n naught. So ln of n naught is equal to alpha x is there. X is means is equal to 0. When we multiplied with a 0 means this term will be 0. Then what is remaining now here? That is integration constant, that is a. So call this equation as number 3. Now substitute this equation number 3 into here. Then what we will get, just right here, ln of nx is equal to alpha into x I will write. Instead of this integral constant, what is there? Ln of n naught. Is it right? Getting all of you? See here. Then ln of nx, I will take this term to the LHS side. Ln of nx minus ln of n naught, this will be equal to what? Alpha x here. We know the formula for ln A minus ln B is equal to what? Ln of A divided by B it is. We know the mathematical formulas, right? So ln of nx minus ln of n naught, I can write it like ln of nx divided by n naught. So this will be equal to what? Alpha x here. So now you apply the exponential terms here. So now let us apply exponential term on both the LHS as well as the RHS. How will write this one? E is equal to exponential. We can write exp also, or we can write E also here. E to the ratio of ln of nx divided by n naught. This will be equal to e to the power of alpha x. It is exponential of alpha x. Then how will write this one? This ln and this exponential will get cancelled. This nx divided by n naught is equal to exponential of alpha into x here. So this is the LHS side and this is the RHS side. I can rewrite the equation like nx is equal to, this term I will take it to the right hand side, n naught exponential of alpha x. So in this equation I can write it like this also, nx is equal to n naught exponential of what? Into the bracket of alpha into x. Is it right? So this is the equation for what? The number of electrons which are reaching to the anode. Getting my point? Once these many number of electrons, if it reaches the anode, means the distance will be what now? X will be equal to the small d itself. Then how will write? Instead of this x, I will substitute this small d. Nd is equal to n naught exponential into the bracket of alpha into, instead of this x, I will write d. Correct? I think this is clear to all of you. Then what is the main intention of calculating or using this equation? The amount of current growth. Is it right? Amount of current growth we are going to calculate now. Then the average amount of the current in the gap. In the gap means between the two electrodes, which is equal to the number of electrons traveling per second. What is the definition for current? Nothing but the moment of electrons, right? The moment of the electrons, nothing but the average number of electrons which are moving from cathode to the anode. This will give the current itself. So how will write the current equation then? Current will be I is equal to I naught exponential of alpha into t here. Instead of this one equation, number of electrons, instead of that I had taken the current here. I, instead of this number of electrons at initially, I will taken the initial amount of the current will be I naught, and this exponential of alpha into d I had written as it is. This I naught indicates what? This is the initial current at the cathode. So by this equation we can calculate the amount of the current which is flowing between the electrodes. Getting my point? So I hope this is clear to all of you. Okay. Thank you.